very good morning, girls. Once again, I welcome to the online classes of the numerical analysis. And in the previous class, we are discussing the concept of the operators, right? And now here I am going to discuss the next formula. So in the previous class, we discussed mu is equal to half of this one, and I gave the question that is mu square equal to 1 plus 1 by 4 of gamma square. Right? We have to prove this one now. Now I hope you know the formula of the mu here. So what will be the formula of this one? Simply mu is nothing but 1 by 2 of e power 1 by 2 plus e power minus 1 by 2. This is the value of mu. Mu square means just we have to apply the whole square for this one. Whole square. So then here what we get? We'll get that it is nothing but simply directly 1 by 4 of e power 1 by 2 whole square a square plus b square plus 2ab. Okay, so now here 1 by 4 of, generally here what I have that 1 by 4 plus, and of course here e power 1 by 2 whole square, that is nothing but e, plus e power minus 1 by 2 whole square, e power minus 2 by 2, that is e power minus 1 plus 2 into e power 1 by 2. Bases are equal, the power should be added. 1 by 2 minus 1 by 2, that means 0. So 0 means 2. Okay, so now here e plus e inverse. So e plus e inverse means we can write it as nothing but, again I know that the value of the e, okay, and I know that the value of the e inverse also, but here what I am doing is I am going to write this e plus e inverse in terms of 1 by 4, because here what I have to prove? I have to prove that it is some gamma, so I have to write it is in terms of the gamma. So see, once where we have the gamma? No, actually we don't have. So actually in essential differences I said that the formula for the gamma, right on, we know that, we know that ఇక్కడ మిడిల్ లో రాసినా పర్లేదు, అలాగే స్టార్టింగ్ లో రాసుకున్నా పర్లేదండి. We know that the central difference gamma is equal to e power minus 1 by 2. What is it? Minus e power minus 1 by 2. Right? So now here e plus e inverse. So here I am taking this value as nothing but e power 1 by 2 minus e power minus 1 by 2 whole square. Whole square అంటే ఏంటి? మళ్ళీ ఇక్కడ a square plus b square minus 2ab. That means minus 2 we will get. కానీ ఇక్కడ మనకి ఏముంది? Only plus 2. So simply what I am doing is I am writing this entire value in terms of the gamma. So then here we will get plus 4. Listen now, why I am writing it here like this means e plus e inverse is equal to e power 1 by 2 minus e power minus 1 by 2 whole square plus 4. Now e power 1 by 2 whole square. Whole square means a square na? So a square means e power 1 by 2 whole square. It is nothing but e plus e power minus 1. Okay, next minus 2ab, that means 2 plus 4. Now what we get? E plus e inverse, of course here plus 2 plus 2. Are we getting same or no? Yes. So that's why here I am writing this entire value like this. Now here 1 by 4 of what is the value? Gamma square plus 4. Now can I write it as a gamma square by 4 plus 1? That is nothing but 1 plus 1 by 4 of gamma square. This is nothing but the value of the mu square. Okay, next write down. Some another question. Now write down. Just put a side heading, otherwise you can take that. Write down. The shift like a question. The shift operator capital E. The shift operator capital E is terms of expressed in terms of exponential function. Exponential function. సో ఒకవేళ షార్ట్ క్వశ్చన్స్లో మీకు ఇవన్నీ అడగొచ్చండి. ఓకే, ఒక్కొక్క రిజల్ట్ అడగొచ్చు. అదర్వైజ్ there is a chance to ask like 2 questions. Okay, so now here there is a chance to ask this question as just express the shifting operator in terms of the exponential. Then you have to give the explanation of this one. Now write down. We know that the shift operator is defined by E of fx is equal to f of x plus h. That means E by r is equal to by r plus 1. Now expanding it by Taylor's theorem, then we get what we get here. First of all, f of x plus h into f dash of x plus h squared by 2 factorial into f double dash of x plus so on. Now అంటే మీరు అక్కడ రాయకండి. సింపుల్లీ f of x, what I am doing is f of x plus h into here f dash of x means d by dx of f of x, isn't it ma? Derivative of f of x. We know that d by dx is denoted with a capital D of f of x. Now it is nothing but d f of x plus h squared by 2 factorial into d square f of x plus so on. Now here I am taking that f of x common. Then 1 plus hd plus h squared by 2 factorial d square plus so on into f of x. So it is nothing but E of f of x is equal to this one. Now we know that actually e power x, otherwise simply see here I am giving the value e power x can be written as exponential function 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. This is an exponential function, expansion of the exponential function, and here it is nothing but E of f of x is equal to, in the place of x what I have, hd. So e power hd of f of x. Now simply E is equal to e power hd. So the shift operator is expressed in terms of the exponential function where x is equal to hd. So this is nothing but the formula. Of course you have to take this one, you have to prepare this proof also. Okay, so next item. I am giving one application. Of course, okay, first of all I will finish all the formulas related to the operators, and after that we will discuss one application related to the difference table, and then we will go for the next chapter. Now write down. Prove that backward difference, forward difference. Okay, the product of the forward and backward is equal to, difference between the forward and backward is equal to gamma square. This is the relation and we have to prove this relation. Okay, so now write down. We know that what is the value of the backward difference? It is expressed in terms of E inverse. And what is del value? It is nothing but, we know that E is equal to 1 plus del. Now del is equal to, it is nothing but E minus 1. So now here, first of all, this is a question and this is a proof. Now what I have? Backward into forward. What is backward? 1 minus E inverse into, what is forward? E minus 1. Now 1 into this one, that means E minus 1. Next, minus E into E inverse minus into minus plus 1. Now both will be cancelled. So then finally what I will get here? Minus 1 plus 1. Sorry. E minus 1. 1 into E 1 minus 1. Okay. Minus this one, minus into minus plus E inverse. Because E inverse into this one. Now here what I will get? E minus 1 minus E into E inverse. The basis are equal, the power should be added, then it is 1 plus E power minus 1. Now E minus 2 plus E inverse. That means E plus E inverse minus 2. This is nothing but the value of the product of the forward and backward. Okay, now here this is the value and I am taking, just unboxing it. Next what I have that for del minus backward operator. What is the value of the del here similarly? Now here del means E minus 1 minus 1 minus E inverse. Then E minus 1 minus 1 plus E inverse. Now E minus 2 plus E inverse. And take it as equation number 1 simply. Okay. Now E plus E inverse minus 2. This is nothing but del forward minus backward operator. Okay. So differences. And now here we have the two results. Next what we have to do? We have to take that gamma square. That means second order central difference. Now write down. Now consider the second order central differences. Central differences are given by del square y1. So del square y1 will be the differences between the previous value. If you see the central difference table, then you can take the del y 3 by 2 minus del y 1 by 2. The difference between the middle. So now here again it is nothing but this is the value. Okay. So now here y1 equal to what is the value of gamma of y3 by 2? So now here I will give that. Already I mentioned that y3 by 2 is equal to gamma y1. Right? And of course here another one write down. Gamma y1 by 2 is equal to gamma y0. So now here y3 by 2 means generally this value is nothing but gamma of y1. Otherwise here del y1 del y0, because we know the relation between these I gave, right, between gamma and backward, forward, backward, center. So now here I have that 3 by 2 and this one. So now here what I will get? Del y1 minus del y0. Okay. So otherwise write down, before starting this one, just consider the del square, second order central differences, and we know that gamma of y3 by 2 is equal to del y1, gamma of y1 by 2 is equal to del y1, and y1 equal to e y0, because we know that e power n yr is equal to yr plus n. Okay. So now here I have to know about a 1. That means r is equal to 1 and n will be different. Otherwise, if you get any confusion, then you can take that e. Okay. Now here y1 I have to know. So that's why here simply I am taking that y1 is equal to, okay, r, just put that r is equal to 0. So if r is equal to 0, then you will get this one. Okay. Now write down. And by using all these formulas, we have right. So now here del square y1 is equal to, now I changed the gamma to del, central to forward. Now del square y1 equal to del y1 minus del y0. So same del of, what is y0 from here? Y0 is equal to y1 by e. Now y1 by e. Okay. So then here I am taking that del square y1 is equal to del minus del of, otherwise here what we can take, y1 common, so that's why del by e of y1. Now y1 get cancelled now, so then what we get, gamma square is equal to del minus del by e. Now we know that del value, that is e minus 1 minus e minus 1 by e. Now LCM, then e of e minus 1 minus e minus 1 by e. Now it is nothing but e square minus e plus 1 by e. Okay, so now here, which is equal to e square minus 2e plus 1 by e. So now here finally I have that e square and so on. Now actually in the denominator I have e, so I am taking that e common from the numerator. Then what we get, e minus 2, and here e square minus 2e plus, I am writing it as e into e inverse by e. I am taking e common from the numerator, then e by e minus 2 plus e inverse, because here I took e outside now, so that's why we will get like this one. Now e get cancelled. Finally here what I have that the result is e plus e inverse minus 2. It is equation number 3 and it is equation number 2. So all these equation 1, 2, 3 are all equal. So that's why here what we can say? We can say that therefore the result, hence the result. So simple thing you have to remember these two formulas. And next you will get two results. Then for the gamma square we have to consider these three formulas. Okay, so this is nothing but the required proof. And next write down. Prove that. Next question. Prove that mu into gamma equal to 1 by 2 of forward plus backward. Okay, now first of all here what I am doing is I am taking that 1 by 2 of forward plus backward. So I have the operators already. So now here first of all we know that. So it is nothing but just of course here I gave that this value is nothing but, this is nothing but in inverse, and this is nothing but e is equal to 1 plus delta and delta is equal to e minus 1. So now here consider 1 by 2 of forward operator plus backward operator. Now 1 by 2 of, what is forward? Forward is e minus 1 plus 1 minus e inverse. 1 by 2 of e minus 1 plus 1 minus e inverse. Okay, here what we get? We will get that 1 by 2 of e minus e inverse, because plus 1 minus 1 get cancelled. So now here we have that it is nothing but e minus e inverse. Now what I am doing is I am writing it as 1 by 2 of what I have, e minus e inverse. Now I am trying to write it is in the form of, generally what I have mu into gamma I have to get, which is equal to this one. So now here I am writing this 1 by 2 of simply e minus e inverse can be written as e power 1 by 2 plus e power minus 1 by 2 into gamma. So in the place of gamma we can take that directly here. Okay, in the previous one I said that is nothing but e power 1 by 2 minus e power minus 1 by 2. Okay, so now listen. E power 1 by 2 into this value. Then e power 1 by 2, e power 1 by 2 is basis hypo, the power should be added. Then we will get e. Okay. Next term. Plus into minus minus e power 0. That means 1. Next, plus e power minus 1 by 2, 1 by 2, plus 1 again, minus, plus into minus minus e power minus 2 by 2, 2. Then it is e power minus. It can be written as the product of the a plus b into a minus b. And we know that mu is nothing but the average 1 by 2 of average. So it is nothing but mu. This is nothing but mu. And this is nothing but gamma. So therefore finally we have that which is equal to mu into gamma. Okay? So మీరు ఏం చేయాలంటే ఇవన్నీ గుర్తుండాలంటే క్లియర్గా ప్రిపేర్ అవ్వాలి ఫస్ట్ ఆఫ్ ఆల్, ఎందుకంటే ఈ ఆపరేటర్స్ అన్ని మీకు న్యూగా వచ్చాయి కాబట్టి. అండ్ నెక్స్ట్ యూ హ్యావ్ టు రిమెంబర్ దీస్ ఫార్ములాస్. ఓకే, నెక్స్ట్ ఐడమ్. Using the method of separation of symbols, show that write down the question mark, in the part only. Del u x minus n equal to ux minus n into ux minus 1 plus n into n minus 1 by 2 ux minus 2 plus so on plus minus 1 whole to the power of n ux minus n. This is the result we have to prove. Okay, so now here to prove this one, what I am going to do is I am going to take the help of the first of all inverse operator. Okay, so otherwise in a simple way I will discuss. Okay, so first of all here write down, here we will prove this by taking the concept of RHS equal to LHS or LHS equal to RHS. And we know that e power n by r is equal to by r plus n. Okay, now write down. Now consider the RHS. What is RHS? ux minus n into ux minus 1 plus n into n minus 1 by 2 ux minus 2 plus so on plus minus 1 whole to the power of n ux minus n. This is nothing but RHS. Now I am writing this RHS as, write ux, listen carefully ux minus what I have n only. So here I am taking the directly n. Next here what I have in the place of yr, I have that u. Okay, in the place of y I have u, in the place of r I have x. Now it is in the form of ux minus 1 is in the form of yr plus n. So what is n value? E minus 1. So then can I write this value is equal to e power minus 1 ux. Okay, and similarly ux minus 2 is equal to e power minus 2 ux. Okay, then so on. Otherwise here I am writing by using shift operator, ux minus 1 is equal to e power minus 1 ux minus 2, మీరు ఇది స్టార్టింగ్ లో రాసేయండి, equal to e power minus 2 ux minus, we don't have 3 now, so directly 3 is equal to e power minus 3 ux and so on ux minus n is equal to e power minus n into ux. Okay, now here I am going to substitute all those values. Then what we get, n into e e power minus 1 ux plus n into n minus 1 by 2 into e power minus 2 ux plus so on minus 1 whole to the power of n ux minus n, that means e power minus n ux. Okay, ఇది మీరు రాసేసారు కదండి. Now I am erasing this one. Now which is equal to, I am taking that ux is common because in every term I have a ux. Now 1 minus n into e inverse plus n into n minus 1 by 2 e power minus 2 plus so on minus 1 whole to the power of n e power minus n of ux. Okay, so now here we have that some RHS is equal to this one. Now totally we have that the RHS in terms of the ux as well as in terms of the e. Okay, so now here this is nothing but actually this entire value is nothing but the expansion of 1 minus, here what we have e inverse. Okay, that means x. So here generally we have the formula is nothing but 1 minus nx plus n into n minus 1 by 2 into some x square, like that we have to get. But here in the place of x what I have e power minus 1. Okay, and next here what I have n, that means whole power n. If I have n is equal to 1, then we will get some another expansion now of ux. Okay, because here 1 minus x inverse whole to the power of, మీకు generally 1 minus x whole power p అనే ఫార్ములా ఉంటుందండి. ఇక్కడ 1 minus e inverse whole power n is nothing but 1 minus n into e inverse plus n into n minus 1 by 2 e power minus 2 plus so on. Okay, so now here we have like this. Now actually here what I have to prove, just see that we have to prove that the LHS is nothing but simply del power n into ux power n. So that's why here what I am doing is, so I have to prove that it is equal to del power n is, sorry, del power n of ux minus n. I have to prove this one, and we know that the value of the del is nothing but what is the value, that is e minus 1. So I have to get first of all e here. That's why 1 minus, e minus 1. So that's why I am writing like this, n into u of x. By taking the LCM, what I get here, e minus 1 by e whole power n ux. Now can I write it as a e minus 1 whole power n by e into ux? Yes, we can. So next here I am writing here now. Next, which is nothing but here what is the value? This is nothing but del. So del power n into here what I have, of course here e power n. Okay, a by, I am splitting that fraction now into e power minus n into ux. Now del power n, and we know that e power minus n means here what we get in the previous one, we consider that ux is equal to e power minus 1 into what I consider n into, yeah, this one only, right? Sorry, ux minus 1. Okay, ux minus 1 is nothing but e power minus 1 into ux I consider this one. Now here what I have, e power minus n. Minus n means minus 2, minus 3, minus 4 we will get. The meaning of this one is, listen carefully, e power minus 2 ux, no? Right? So now here I have that e power minus n ux. Now similarly, if I take up to x power n minus n, what I am getting, e power minus n ux. So now here can I write it as nothing but u x minus n, no? Therefore which is equal to LHS. So therefore finally RH is equal to LHS. So here I proved this one, and here you have to remember few points. Firstly, the thing is nothing but you have to take the help of this definition. By the definition only we are solving the entire problem, and you have to remember these values. Next, substitute these values in a RHS, and then you have to take the ux common. Then simply you have to remember this expansion also. And next, simplifications. E power minus 1 means we can write it as a 1 by e, and so on. Okay, so this is nothing but the proof related to the method of separation and by using the method of separation we have to show that, right? That is a question. And yeah, with this this class is finished. In the next class just we have to discuss one more result, and of course no need, but I want to. So with that we can finish this chapter, and nextly we have the polynomials. Okay, and the polynomials, of course, it is somewhat easy to you, and you can understand easily, and you can remember easily also. Okay, and thank you everyone. Have a nice day.